All right, before we do the next example and keep going with the law of cosines, whenever we are solving, notice that in the last two examples that we did, we ended up with an oblique angle, right? And so the largest angle, and by the way, we also chose the largest angle to solve. And so there's an important part, it's wise to do that. But before we get into that, the cosine of the angle will tell us whether that angle is oblique or acute. So remember, if cosine is positive in the first quadrant and negative in the second quadrant, so if it's between 0 and 90 degrees, you're going to get positive angle, so that means it's acute. If you're between 90 and 180 degrees, which is obtuse, then cosine is going to be positive, or excuse me, negative. Okay, so that's important. Okay. Also, we want to start and find the largest angle. And remember, the largest angle is always across from the largest side. So that's why in the last two examples we did the angle that was across from the largest side. And the reason that is if you know, obviously if that angle turns out to be acute, right, then we know that all the other angles are acute, right? And if that angle turns out to be obtuse, then we know that the other two angles are acute. So it's always wise for that reason to start with the angle across from the largest side. What else do I want to say here? Yeah, no, that's it. Okay, so let's do example 2. Side angle side. Okay, so here's what we have. Okay, so here's what we do. Now, in this case here, we've got side angle side, so we've got the included angle, and so in this case here, we're going to use the standard form to find A, this side over here. So we'll do that first, okay? So we're going to get A squared is equal to B squared plus C squared minus 2BC cosine A, right? So there's the standard form. And now we're going to plug in the values that we know, right? So B and C, we know B and C, we know the included angle A. And so now it's going to be 9 squared plus 12 squared minus 2 times 9 times 12 cosine of 25 degrees. So this is going to be 81 plus 144 minus 216 cosine of 25 degrees. Okay, and then that's going to give us approximately A is going to be approximately, because we have to take the square root, right? So if we do A equals, we're going to take the square root of this, and that's going to give us approximately 5.4072 meters. Okay? Now, of angles B and C, angle B must be smaller, right? Because C is across from the larger side, right? 9 is smaller than 12, so angle B has to be smaller than angle C. Okay? So B cannot be obtuse and must be acute. And because you know A, we know A, and we know the angle A, and we know side B, we're going to use the reciprocal form of the law of sines, right? So we know this has to be acute, so let's find B. So we're going to do sine B over B is equal to sine A over A. And so we get sine B equals B sine A over A. And so now if we plug in the values, B is 9, and then sine of 25 degrees over A, which we found to be approximately 5.4072. And if we take the inverse sine of both sides, we get B is approximately equal to, what do we get? We get 44.7 degrees. Okay, so 44.7 degrees. Okay, A is approximately 4.70, oh, excuse me, 5.4072. Okay, and so now C is easy because now all we have to do angle C. C is going to be 180 degrees minus 25 degrees minus 44.7 degrees, which is going to give us 110.3 degrees. Oops. Okay. And we're done. Not bad. Now, when solving an oblique triangle, given two sides and the included angle, so in this case, SAS, side angle side, we're going to use the standard form for the law of cosines, which is what we did here. Okay, so side angle side, we're going to use the standard form. Have a great day.